Next topic after electromagnetic wave theory, characteristics of wave and electromagnetic spectrum that we have covered up is limitations of electromagnetic wave theory. Electromagnetic wave theory could not explain some of the phenomenon like black body radiation phenomenon. Then it could not explain photoelectric effect. And third problem in this theory was it could not explain the spectrum of atoms, particularly of hydrogen atom, So now one by one we'll cover up all these 3 points. Now what is first of all black body radiation and what was not explained by electromagnetic wave theory about black body radiation? So our next topic now is black body radiation. To understand black body radiation, first of all, I'm taking an object like this, some object, a body like a matter, and white light is falling on this. White light will have all the color wavelengths in it, like lambda 1, lambda 2, lambda 3. I'm showing that all color radiations are falling on this body because we are taking a white light which is made up of 7 colors. So all wavelength radiations are falling on this body. So what this body will do? Now it will absorb some of the radiations, wavelengths falling on this, and some of these will be reflected by this body and some radiations will be transmitted by this body. And this radiation that is reflected by the body, the corresponding color of this will be seen of this body. Suppose blue color is reflected, so this body will look like a blue color to us. So the color of the body depends on the radiations which are reflected by this body. Now if we'll take this body and now start heating it, same body we are taking, and we'll start heating it. What will happen when we'll heat this body? Now all wavelength radiations are emitted also by this. If it can absorb all wavelength radiations, on heating it will emit out all wavelength radiations also. Like you can say lambda 1, lambda 2, lambda 3, if we'll designate these like this. So all wavelength radiations are emitted also by this body. So now we will plot a graph taking the wavelength of the radiations which are emitted, these radiations, we are taking the wavelength of these emitted radiations, and the other side we are taking the intensity of these radiations. Intensity means amount of radiations emitted. So you can write here, intensity means amount of radiations emitted, because all these will not be emitted in the same amount. Some will be emitted more, some will be emitted less. So amount of radiations emitted. The graph will be like this. This kind of a graph will be observed. So some of the radiations are emitted less. Which radiation are emitted less? The ones which will have less wavelength. And here also some radiations are emitted less because see here the wavelength of these is the maximum. So minimum wavelength and maximum wavelength radiations are emitted less. But here we have this peak represents more radiations are emitted of this particular wavelength, because here we are getting the maximum intensity. So maximum radiations emitted are of this particular wavelength. More radiations of this particular wavelength are emitted. And this we are designating as lambda maximum, because maximum we are getting these radiations of this wavelength we are getting. So now we are taking a black body. This is the normal matter we have taken, simply body. When the light is falling on this white light, what is happening to this, and when the same body we heat, what will happen, and this kind of the curve we should get. Now we take a black body. That is also a matter only, but there will be a little different behavior in case of black body. What is a black body? First of all, black body, it is a perfect absorber and emitter of radiations. Now, what is the meaning of perfect absorber and emitter of radiation? On this black body, when radiations are falling, so it will absorb all radiations falling on it. That means it is a perfect absorber of radiations. This body is absorbing all the radiations falling on it. That means this is a perfect absorber of radiations. Now what we'll do is this body, same body, we will heat it now. On heating this, what will happen? All wavelength radiations are emitted also by this body. So no wavelength radiation will be left inside, all radiations will be emitted by this. So now we'll say that it is a perfect emitter also. So this kind of body, which is a perfect absorber and emitter of radiation, this body is known as black body. So now we are taking the black body to do the same phenomenon that we were doing here, this thing. So same thing, same kind of graph we will plot for this black body also, and see whether we are getting a same graph or the graph is little different. In this case, again, one side we are taking is wavelength, other side we are taking is the intensity, and actual curve is like this. But when it is plotted for the black body, this graph curve was like this. This kind. So this is the theoretical and this one is actual. So for most of this wavelength part, see the two curves are just coinciding with each other. So we can say to some range of wavelength, this range of wavelength, to some range of wavelength, both the graphs, they match. But where the two graphs are different, when the wavelength is less, for the less wavelength the graph is different. For small wavelength there is a difference. So why this difference is coming? This is also a matter only, so all the bodies should behave in a same manner only and we should get this kind of graph. Why in black body we are getting a different kind of a graph? Similarly, if we take a ball and we heat it, iron ball we are taking here, iron ball, and when we heat it, on heating, first of all, its color is red. That means maximum radiations of red wavelength it is emitting. Now further heat it and color will change to yellow. That means on further heating, now the radiations of which color are emitted maximum? Yellow color. On heating further, the color will become white. Now the radiations of white color are emitted maximum, means all color. On further heating, this becomes blue. That means at this time, the maximum radiation emitted are of the blue color wavelength. So now why the color is changing here? According to electromagnetic wave theory, radiations emitted by a substance are continuous. Continuous means they should have one kind of energy, one kind of wavelength, so one kind of color only it should emit. Why the colors are changing here in this case? So if the substance being heated is a black body, which is a perfect absorber or emitter of energy, the radiations emitted out by this is known as black body radiation. And according to electromagnetic wave theory, energy is emitted or absorbed continuously. So it should have same intensity. Same intensity means it should have same color. But why the color is changing here? That means if we are not getting the same curve here, same graph, we are not getting actual and theoretical ones are different when we apply it to the black body. There's some problem in explanation of electromagnetic wave theory. So this behavior of black body we cannot explain taking the electromagnetic wave theory. So this is a drawback of electromagnetic wave theory. It could not explain black body radiation phenomenon.